In this video we are talking about energy, and the first topic in energy is called work. And energy is actually defined as the ability to do work. And by work, we always use the formula work equals force times displacement, so W equals Fd. And the units that we talk about with respect to work, you can say it's Newton times meter or Newton meters, or J stands for joules. So I said work equals force times distance. Well, remember, we know from one of the Newton laws that force, or F net, equals mass times acceleration. So if we put ma in our formula instead of F, we get work equals ma times d, which spells mad, might help you remember it. And then acceleration, when we're talking about work, we're usually talking about dropping an object or lifting an object over our head or something like that. So in that case, the acceleration comes from the force of gravity. So you can simplify work equals Fc down to W equals mgd. Work is equal to the measure of mass times the force of gravity times the displacement. So we'll do 3 examples here. The first example will be sort of the standard, easiest sort of question you would hope to see. Then we'll do one where we're dragging a box and our force is on an angle. And then we'll do one where we actually have negative work. And you have negative work, things like trying to stop a car, or you're on ice skates and you're trying to stop, situations like that. So the first question I've got is 10 next to Dean. He lifts the Stanley Cup from the ice. The Stanley Cup weighs about 15.7 kilograms, and he lifts the Stanley Cup to a height of 2.5 meters. How much work is Henrik doing on the cup? Well, first I would write down all the information you've got. We said the mass is about 15.7 kg. We are lifting it to a height, or a displacement, of 2.5 meters. And the force of gravity is just a constant. It's always going to be the same, 9.8 meters per second squared. So I said force of gravity, I meant acceleration due to gravity. So I think we have everything we need to plug into our formula. So work is going to be m, it's 15.7, times g, which is 9.8, times d, which is 2.5. And when I did that on my calculator, I got that that was about equal to 385, you could say Newton meters, or you could say joules. So that's all you have to do for a question like that. Let's do one that's a little bit more difficult. Let me erase this. Okay. So in this next example, we've got a 100 kilogram object, and it's being pulled in this direction by a force of 75 newtons. Now, it's on a frictionless surface, and the angle of the force to the surface is 40 degrees, and it's being pulled over a distance of 10 meters. So we're going to use the same formula, W equals Fd. We're being asked to solve for work. So force, well, this force is not in the same direction as the movement of our box, or whatever it is. It's moving this way, right? So we need to figure out, this vector is made out of 2 components. It's kind of like Pythagorean theorem. A slanted vector is made out of a horizontal vector and a vertical vector. So we need to find out, because the box is moving this way, we need to find out what's the length of this component of the 75 Newton vector. To do that, you need to just do some trigonometry. This is the side we're finding, so you can call that x or whatever variable you want. So in our triangle, this would be the 90-degree angle which makes the 75 newton side the hypotenuse. We have the hypotenuse. With respect to the 40-degree angle, this side would be adjacent. So we need the formula that uses adjacent and hypotenuse. That would be cosine. So we'll go cos of 40 equals adjacent, which is x, over hypotenuse, which is 75. So on your calculator, make sure it's in degree mode. Just type in cos 75. I get it's equal to that decimal. Now I'm just going to round that to maybe 0.26, and then I'm going to multiply by 75. And when I do that, cos 40, nope, I typed in my calculator wrong. Sorry guys, that's what you should get for cos 40, about 0.77. I'll multiply that by 75, and I'll get that x equals about 57. So the x component of the force would be 57, and the units would be newtons. So that's the force. I'll plug in up here for F, 57 newtons, times a distance or a displacement of 10 meters. And I get 57 times 10, that would just be 570, and I'll say joules. The last example I'm going to talk about in this video is when you have negative work. And negative work, you might see a situation where a car puts on the brakes and is stopping or something like that. So you have negative work when force is opposite to the direction that the object is moving. So if your object is moving this way, but it's slowing down, so the force being applied on it is maybe the force of friction or the force of braking. When those two forces are going opposite, that's when you have negative work. So we've got the example: a 67 kilogram skier slides to a stop after having previously skied at 3 meters per second, and while the skier is stopping, he or she ends up skidding a distance of 80 meters. What is the work done by the force of friction? So we know the skier is originally at 3 meters per second. When the skier comes to a halt, they would be at 0 meters per second. The reason we are bothering to think about what the final velocity is we're doing W equals Fd. Force is mass times acceleration times distance. In this case, acceleration is not due to gravity, but it's okay because we were given velocities, so we can figure out the acceleration using the velocities. So if you remember back to our kinematics unit, one of the formulas we had said that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. The reason we choose this formula is because we have Vf, which is 0, we have V0, or the original velocity, which is 3, we need acceleration, and we have the displacement, which was 80 meters. So we have everything we need to be able to solve for acceleration out of that formula, so we can plug that acceleration into our formula for work. So 0 squared is 0, 3 squared is 9, plus 2 times 80 will be 160 times acceleration. So I'll just subtract 9 from both sides so that this 9 will go away, and I'll get on this side negative 9 equals, that 9 crosses out with negative 9, 160 times acceleration. So divide both sides by 160. Negative 9 divided by 160, you can do that on your calculator. I get that's equal to negative 0.05625, and its acceleration, so that'll be meters per second squared. So let me just erase this so we can plug it into our formula. We know the mass is 67 kilograms, acceleration is negative 0.05625 meters per second, and the displacement was 80. When you multiply all those numbers together, you get about negative 301.5 joules. It's negative because the force is opposite to the direction the skier is moving. The skier is moving this way, but the force of friction is in opposition to the way he's moving.